Hey, my name is Chris, and today I'll be showing you how to use the Biotage Isolera 1 flash chromatography system. So as you can see, this is the instrument here. Just to orient you quick, the solvent bottles are here over on the left. The waste is all the way in the back, and this is the main instrument here with the fraction collector right underneath it. To start off, the power button is right here. So when the instrument first turns on, this is the menu that you see. Just to orient you, to run a new column, you go to New here. Chemistry here is where you can look at old data. Data administration is for managing the various advanced functions of the instrument. And to turn off, you press shutdown. We'll be running a new column. So the first thing that you need to do is select yourself as a user. If you don't have an account on the instrument yet, talk to Suresh, who is in charge of the instrument. But other than that, here you can select the method. I'm going to go ahead and pick previous run because I've run this particular purification before. And here, total mass, it wants you to estimate the total mass of the amount of material that you want to purify. So the particular molecule that I want to purify is a protected DG, which I ran previously. So I'm going to be using the same method. Depending on the compound that you are going to purify, you can develop a method for purification. This will vary depending on the characteristics of your molecule and how it behaves on, say, TLC. But the concept is pretty much the same. Depending on how it performs on TLC, you can run, just like you would run a manual column, the Biotage can basically run the same thing. So here, I'm going to be running this particular nucleoside in dichloromethane and methanol. I'm going to go ahead and press Create. On the first tab here, you see Gradient. Gradient is going to be the main control of the method. So as you can see here, what this particular method starts off as is 0%. What it refers to here is 0% methanol, or the more polar solvent in your particular mixture. Methanol is more polar than dichloromethane. So that's what this 0% means. It means that for the equilibration, it will pump pure dichloromethane through the column. And then subsequently, this is a rather shallow gradient where it'll increase the amount of methanol over. CV stands for column volumes. But here you can go ahead and press Add or Delete to edit the table. Over on the next tab here, you can select the parameters for your particular column that you want to do. You can change the user, so I'm Chris. The method, so if you wanted to change the method, you can name this whatever you want and then save it as a new one if you've edited it, or if you don't put anything in there, it doesn't matter either. But for sample name, if you leave this blank, it will just put in the date for you, and then comment, you can write whatever information would be useful for you to know in the future. If you want to organize these by project, you can create a project name, whatever your project you may be working on, and then select it here. So this particular molecule is in pursuit of the FAFI project, so I'm going to go ahead and keep that. The next thing here that I want you to pay attention to is for the cartridge type. Now, I've already programmed this instrument to accept these particular cartridges. So the instrument doesn't detect what column you have to tell it what you're running. So all of our columns right now are the SPAR high capacity duo. For the particular separation, I'm going to be running the 25 gram size. And don't touch any of the other parameters because they're already set for you. So all you have to do here is select the cartridge type that you're going to run. The solvent, so I already mentioned that this is going to be a dichloromethane and methanol column. This is where you can change that. So I know that here we only have acetonitrile, ethyl acetate, DCM, and methanol loaded on, but you can change these in the settings. But it's important to realize that solvent A will be your less polar of the two solvents, and then solvent B will be your more polar. If you want to do some fancy chromatography, you can actually add a third solvent or even a fourth solvent. But for now, we will stick with just two, which is standard. Dichloromethane and methanol. And the last thing is the rack. So this is kind of up to you. I only have this particular size rack programmed for right now. And the maximum volume for these is 25 milliliters, but I have it set to 22 just for safety. And then you can pick the dispense order that is more convenient for you. I like S because of the nature of the fraction collector. As it snakes around, there's less of a delay between like this fraction and that fraction. If you pick the Z, sometimes like it takes a second for it to stop and then move across, and it could drip some of your solution into some of your samples. So I personally like the S, but that's all for the parameters tab. And the last tab here is also kind of for advanced users. You can actually change the monitoring wavelength that you are looking at. So this depends on what your compound is more active at. So if it absorbs, in the 254 range, and 280 is just another secondary one. You can change this to whatever you want. But the default is going to be 254 and 280. I don't know that it works super well under that, so I would try other detection methods such as just monitoring manually by TLC or staining for anything other than this. And then the last thing that we should talk about is if you turn it on, it will collect everything that comes off of the column. So especially because today I have a known sample and it's already been purified before, I'm going to go ahead and collect all off. This means that I will only collect when I'm at the threshold that I set. So the default is 200 milliAU, which is going to be fine for me today, but I just want to let you know. Otherwise, if you collect all, the fraction collector will continuously collect fractions for you, but if you turn it off, it will be redirected to the waste, so less work for you if you know what you're doing. If you are not confident in your separation, or say like your material runs really closely to an impurity, I would suggest keeping collect all on. That way that no matter what, you still have everything and you can still play around with it or try repurifying in the future. So that's all for these settings for now. So after you're satisfied with the setup, you can go ahead and press run. This is the prompt for the to start the equilibration. So it prompts you to select the racks that are loaded with your test tubes. So today I only have one rack because I know that this particular separation won't need that many. But you can load up to 4 of these. And by the way, this gray test tube rack, you have to use this with this particular instrument because of the way that the fraction collector is calibrated. But yeah, I'll just go ahead and select rack A, and then as soon as I press this equilibrate button, it will start. So before we do that though, we should take a second to talk about the different columns and how to prepare those. So I briefly mentioned before, we have a couple of different column sizes. We have a 5 gram, 10 gram, and 25 gram. The 25 gram is going to be the one that we're going to be using today. And we actually also have a 50 gram column back there. A question that you might have is, how do I know which column size I should use? Biotage advertises a capacity on here. It's really small, but I'll say for the 5 grams, it says that it can take up to 100 milligrams to up to 1 gram of material. This estimation is based on the total amount of crude material that you're trying to load on the column. So remember back when I said like you should keep track of the total amount of material that you're trying to load? That's what this is referring to. In my experience, I don't think it's that great. So you should be a little bit more on the conservative side. If you have about 300 milligrams to 1 gram of material, I'd say that it's still best to use the 25 gram size just because you will get cleaner separation, especially if this is a reaction mixture. Only use these small ones if you have a very small amount of material. Maybe tens of milligrams for the 5 gram, and then maybe under 200 milligrams for the 10 gram. Anything more than say 1.5 grams, you should try using the 50 gram size. But today we'll be using the 25 gram groups. So this is the column that we're going to use, this is the 25 gram here again. So inside the orange cap, it has this piece of plastic in here. If it's new, this will be intact, so it's still a solid piece, part of the container. We want to keep that in there for equilibration because it will distribute the solvent more evenly. Also, I should mention, one other thing that you should check before you use the column is make sure that the cap has the clear rubber O-ring on the inside. Make sure that still looks okay before you close it. But otherwise, this is the line that we attach our column to. All of these fittings, by the way, are standard lure lock. So you can just go ahead and discard these purple fittings. Here's the top one. The flow goes from the top down to the bottom. And then it's worth noting that on the bottom, they come with straight snap-on lure fitting. We want to remove that because what we have here is the screw-on fitting. It's very important that all of these fittings are as tight as you can get, just finger tight though. So those are nice and snug. And then the last thing is, the cap, you don't want to like over tighten. The O-ring is pretty good, but just tight enough so that there's resistance. And then I have a piece of tape here just to secure it. And then now we can go ahead and press Equilibrate. Assuming that you check all of your solvent levels and make sure that everything is filled. So right now it will equilibrate. So what it's doing now is, remember I said that it will start off with pure DCM. It's preparing the lines right now, and then it's physically pushing DCM through the column. Sometimes, even after equilibration, because this is just an automated program, it won't push out all of the air. In that case, you should exit out of the program and then redo it. This is important because any air left in the column can compromise your separation later on. This is also true if you happen to be reusing a cartridge, which I'll talk about later. So at this point, the equilibration has finished, and as you can see, it's uniformly translucent throughout. This is a good sign. So this column is ready to use. But before we go ahead and do that, I want to turn your attention back to this button. So we just finished equilibration. As soon as I press this gradient button, it will just start running the program. If you can tell, I haven't loaded my compound yet. This is when you would load your compound. As far as these particular columns, there are two major ways that you can load your compound. You can either do wet load or dry load. Wet load means that you dissolve your compound in the minimum amount of the least polar solvent that it's soluble in, and then you can either load it directly through the top using a syringe, because this is a lure lock fitting, or you can drip it through the top with a pipette or something. So this is very similar to running a manual column. If you can imagine, once you load and equilibrate your manual column and you're ready to load on top, you would just use the pipette to drop your compound on top. This is the same kind of concept. The idea is you want to get a uniform layer of your compound if you're doing that. The other method is dry loading, which means you will first dissolve your compound in whatever it's soluble in. It may be methanol, it may be DCM, and then adsorb it onto silica. That's usually what I end up doing, but it depends on characteristics of your compound. Some tips I have. So as far as liquid loading, only wet load if your compound is very soluble in a small amount of relatively non-polar solvent. So in this case, we're running a DCM and methanol column. So DCM is going to be my least polar solvent of the two. And if my compound is very soluble in DCM, which this one happens to be, you can go ahead and dissolve it in the minimum amount and then load it as concentrated as possible. This is to prevent dilution of your sample. Just like a manual column, if you load too much volume on top, your sample will become dilute, and as the column runs, it will start slowly streaking through instead of coming through as one band. You don't want that. You want it to come out as concentrated as a single band as possible. As far as dry loading, which is usually what we end up having to do for most compounds, which I'll show you today, we have to do a couple things. So I have here an old column. This is the one that I've labeled here measurement. Here, we're going to use this to measure the amount of silica we're going to use if we're going to dry load. So I showed you before that there was a solid piece of plastic here. I've already broken it off in this case, and I'm using this as a container to measure the amount of silica that I need to run the column. So depending on the amount of material that you want to purify, you have to decide how many runs you want to do if you're loading it by this method. So I think that this will be, I think one run will be good enough for this particular amount. So I will only load one capful up to this black line. I should mention, it's really difficult to see, but I've marked with the black line. It's not really obvious. So what I want to show is, on the inside of the cap here, the fill line is not actually any of the threading. It's not really marked, but there's a little plastic ridge on the inside there, which I've marked with in black. That's the fill line. So ideally, so it's not actually very much, and it's going to be about halfway full, looking on straight like this. If you want to do more than one run, you would do more than one capful. So say you want to do 2 runs, you would do 2 capfuls like that. Since I only want to do 1 run, I'm just going to fill it up once. So to do that, I have here some bulk silica. It's worth mentioning, bulk silica is a health hazard. You make sure you measure and work with this in the hood. So I'm going to move over to the hood now. So in order to dry load, first thing is you want to take your sample and dissolve it in the least amount of solvent that it's going to be able to dissolve in. And then we're going to go ahead and measure out that 1 capful and add it to the flask. I like to use this cap as a little bit of a tray. It doesn't have to be exact. This is just so that ideally there's enough silica on the inside to make contact with the orange cap that we're going to screw on. That prevents it from, if you have too little silica, then you can have some like swirling of the solvent in the top, and that can dissolve and dilute your sample a little bit, and then also cause it to streak. So, and if you have too much, you will ruin the seal on top because you won't be able to close it all the way, and it may leak. So this is kind of the happy medium. So once you've measured out the amount of silica that you need, I highly recommend using a funnel to transfer. But go ahead and add it directly to your flask. And then, so right now you can see that it's kind of desiccated and kind of dry. We're going to add just enough solvent to have it as a slurry so it's runny. So this is in the case of a already purified sample that I just re-dissolved. If you have a reaction mixture, depending on what the solvent is, you can just directly pour the silica on top of into your reaction mixture and then dry. So what I'm going to do now is go ahead and concentrate this on the rotovap. I'm going to be using. So what I'm going to do now is I'm going to be concentrating this on the rotovap. It's important to note that because I have silica gel in there right now, it's a solid and it's a very fine solid at that. So what we need is a glass frit to protect the lines and the rotovap. I'm going to go ahead and attach that, and then what we'll do is evaporate most of the solvent by rotovap and then finish the drying process on the high vacuum. So you want to rotovap as much of the solvent off as possible. Sometimes that's not going to be very easy. So we'll have to use a combination of the rotary evaporator and the high vacuum. So at this point you can see that the silica is nice and fluffy already. That's about as good as the rotovap can do. So I'm going to go ahead and stop it. And then we're going to finish on the high vacuum. So I have here a gas adapter. We're going to move over to the quickly attach it to the vacuum. You'll see that it starts to dance. As long as it's moving like this, it looks like it's boiling, right? As long as it's moving, that means that there's solvent in there and it's leaving. So ideally, we keep it on the vacuum until it stops, so it's completely dead. That'll be the hard part. Actually, while we wait for this, there are a couple things that are important to remember about this. So I loaded this in DCM. DCM is also the non-polar solvent of the two in the column that I'm going to be running in just a second. So ultimately, I can get away with having some DCM here, as I'll show you over there in a moment. But depending on how you load it, you have to think about how that will affect your column. So say you just did a cross-coupling reaction, a Sonogashi cross-coupling reaction or something, right? In a polar solvent such as dimethylformamide, then you want to make sure that absolutely every drop of the dimethylformamide is completely gone before you run the column. Same with things like methanol, tetrahydrofuran, stuff like that. If you load it onto the column while you still have a polar solvent in there, or maybe like an amine that you haven't removed completely, think about what will happen. If you are loading it onto the column and you have a polar solvent, then because as you run the column, you're increasing the amount of increasing the polarity of the solvent that you're running through. Any amount of methanol in there will ruin your separation or cause your compound to prematurely run. So this step is actually very important to make sure that all of the solvent is removed. So I'm going to go ahead and clean that up. So again, because this is in just DCM and I'm about to add DCM to it, I can get away with just going ahead and running my column right now. I'll go ahead and take it out. But again, if you have methanol or some other polar solvent, you have to make sure that you get absolutely all the solvent off. So once you've dry loaded your sample, you can go ahead and load. So again, we are just at the step where we've equilibrated but have not pressed the button to run the gradient. At this point, you can go ahead and open the cap, and there may be some solvent in there. So there isn't anything in there right now, but if there was, you can pour it off. At this point, because I'm dry loading, again, this piece of plastic I have to break off before I use it. So it just takes a gentle snap. And then that's the cavity that we load our sample in. Go ahead and pour off that excess solvent. Fix it there. And then all we do is go ahead and load directly in there. So you can see that's why we use that old column to measure out the amount of silica. So now we actually have an option. Because I know how this behaves, I'm going to go ahead and fill the top with DCM also. You can just go ahead and close this and hit run, but there's still air in with the silica, right? And when you start running it, the air will start running down and it can cause problems with the separation as well. So to mitigate that, you can actually use a little bit of DCM and load it with your sample. So it's as if you loaded your sample as a slurry. This will prevent the air from going into your column, or at least mitigating that effect. And it also serves to rinse your flask. So what I'm going to do is top off, and then I'm going to be tapping it. So I topped it off with DCM, and then I'm tapping it to get rid of as many of the air bubbles as possible. You can see the air is escaping. Again, this is just to minimize the amount of air that actually gets into your column, because those air bubbles, as they streak down, they can carry some of your compound with it, and that can cause problems with separation. Ideally, your entire column is uniform and packed the same way. Oh, good. After you're satisfied with your loading, go ahead and again check that O-ring to make sure it's there. Go ahead and screw on fairly tightly. So you want to make sure that it's on pretty tight. And then before we hit that gradient button, I want to check all the fittings again. Make sure everything is at least finger tight. After you've dry loaded and are satisfied with all of your settings, you can go ahead and press the gradient button. Again, as soon as you press this, it'll start. What first it does is zeros the UV, so you have a second here. It's running it a 0 to the UV baseline. While it's running that, it's worth talking about some of these functions on the side here. So to watch the chromatography in real time, you want the status tab, that's what we're on right now. But if you want to change the method or something like that, you can always go back here to method. And then later when you're done, the results will be saved here. But the most important tab to think about as far as setup is the setup tab here. This is where you can monitor the fill on all of these. And then it's doing a gradient flush. So now it's starting the actual gradient. So again, I turned off collect all, but at any point, if I want to turn it back on, I can go ahead and hit this button right here. I'm not going to do that though. So right now, this number right here is showing 0, methanol 0. That is currently the percent of methanol that is running through the column. Right now it's 100% DCM, 0% methanol. And then these little numbers here, wavelength all is the overall amount of stuff. It's a measure of basically the amount of UV active stuff that's going through the column right now. Usually it spikes at the very beginning, but that's meaningless. But as far as here, you can also watch the 254 and 280 if you're looking for that. Some other functions while we're kind of waiting for some action to happen. You can go here and zoom. So if you select that, you can zoom in on a particular area that you want to look at. And then you can press full to zoom back out. If you press the length unit button, it will toggle the unit that is on this axis here. CV again stands for column volumes. So a column volume is the amount of solvent that fills the void space in between the actual physical silica particles in the column. If you toggle it, it goes to time or milliliters, depending on what you're used to thinking about. In any case, we should turn our attention to the actual column now. So while the column is running, you can see that there is something yellow running through the column, right? I don't remember whether that is actually the compound or some impurity. I remember actually that the compound of interest, in this case, the protected deoxyguanosine, should be pure white, but it always co-eluded with some impurity. I believe the yellow band that we're seeing here is mostly the impurity, but unfortunately it co-eludes with the compound of interest as well. But you can see that just like a manual column, you can physically observe the compound running through the column in real time. This is only really the case with visible compounds though. So, unfortunately, sometimes your compound won't be visible like this. But in that case, there's still some things that you can look out for. So one thing to note is that when you have pure DCM in this column, it looks fairly opaque, right? But with experience, you'll notice that if you increase the amount of methanol in the column, actually the opacity will change. So you can use the change in opacity or like how the column looks to determine where a compound is. You can't always, but that can help. So that'll probably take a second to get through the column. Let me go ahead and put that back. But let's talk about like what if something goes wrong or something goes on that you want to change. So at any time, you can go ahead and press the pause button. You shouldn't do this for extended periods of time because, again, your stuff dispersed through the column, but you can always pause, and then as soon as you pause, you can actually go ahead and hit the edit button, and you can edit the method in real time. So say I wanted to increase the column volumes of 3% for whatever reason, just make that longer. I can always add a column volume or whatever there and edit the method in this way. Go ahead and do that though. Just to show you, but because I don't anticipate any issues right now, I'm going to just resume. I believe this compound should elute at 4 to 5%, and we're at 3% right now, so it'll be coming through soon. With these nucleosides, a lot of the times what will happen is it doesn't run for the entire beginning, and then all of a sudden it reaches that critical threshold, and it just all comes at once. I think we're going to see that. It's going to speed up soon. It's at 4%. Because the sample is a little bit old, I believe this faint orange right there that we see is the DMT group, the dimethoxytridyl group. Over time, that protection group just kind of comes off, and that orange color is characteristic of that. It should have come out all the way if it were just DMT, but it's possible that there's a little bit that's stuck onto the column making that color. So you can see that's a dramatic change, right? The opacity is changing here. This is what I was talking about. I believe that the yellow that's coming out right there in front is an impurity, and then most of my compound is that opaque white band. It's just because the refractive index is different compared to the background, which is just DCM in the column. So that's a pretty cool way that you can see your stuff moving through. And based on this, you can react to it. You can change, actually this is an important button to talk about. This button right here, so I'm going to go ahead and press collect all. But when it's collecting, you can press this new fraction button, and this is going to be your best friend during a separation. So what I'm going to try to do is, when this comes through, I'm going to press new fraction to kind of divide this up. Because it's not going to automatically change a fraction for you unless it's filled up. So new fraction allows you to just manually force the instrument to separate into new fraction. Do you see how the yellow band is just running together now? Like the separation is not the same. This is what I was talking about, how it just kind of coalesces. That's actually a drawback of this particular instrument. It's worth noting that when it says 4% there, it's actually 4%. And like when it says 1%, that's a whole 1%. It doesn't do like 0.5%. It just goes to the next closest integer. So here it is. We go ahead and press the new fraction. So it switched over. I'm going to zoom in so we can see a little bit better. So you can see this is the major peak. The UV just shot up, right? That's because literally the compound is moving through the UV detector right now. New fraction. So you can see that peak is really big. As far as this particular separation, you can see in the beginning, there was a little bit of a peak, and then here's my major peak right there. I believe that this in the front is mostly that yellow compound, and that this here should be my compound of interest. I believe the yellow is an impurity. So, as you can see, the peak has fully eluted. So both on the UV trace, I can see that there's nothing, and the column is visibly clean. So at this point, we can actually go ahead and stop, just to save solvent. And also because I'm confident that I've already purified this many times. And because I know that everything has eluted, I will just go ahead and end instead of abort. It'll flush the lines. So we've seen that the peak is there, but how do we know which fractions we want to collect? So here, this screen here shows you that all the fractions that we've collected so far, and they're numbered. So remember that we chose the S kind of snaking pattern for the fraction collector. That means that this 1 here corresponds with the first fraction. So this is fraction number 1, 2, 3, 4. As you can see on the trace here, those all contain nothing, so I'll just go ahead and discard those. And the first one here, so this is number 5. This is the blue fraction right there. I'll probably discard this too. But what you should do to check all these fractions is to monitor them by TLC to make sure that they align with your expectations. Fortunately here I only have like 3 fractions, so it's really easy to just test all 3 of them. But if you have a lot of them, a tip I have is you can do every other one and then see which fractions contain your compound of interest by TLC, and then you can refine your TLC search for the place where there's a cutoff, if at all. And you can collect fractions that contain just your compound, and then you can collect fractions that are still contaminated and you can rerun later. But as far as running, that is it for this run. So after you finish, there are a couple things that we want to do. So if you are going to use this later in the day, but you don't want to remove your column yet, just turn the lamp off. So I'll go ahead and do that. It's important to turn the lamp off because that saves the lamp hours. It will burn out over time if we keep it on for too long. So right now the lamp is off, but pressing the remove button will enable you to just go back to the main menu. So this saves your run here in the archive. So say we're back at the main menu and you want to go look at the data that you just got. Where do we find that? So under chemistry here is where we're going to find data. So back here, this is the method that we just had. But in order to view our results, we turn our attention to the results tab down here. Go ahead and press that. And then you can select which run that we did. So here, this is the last run that I did. These are all runs that I've done in the past. But this is the last one I did. And then if you go to report setup, you can zoom in and look at your fractions. So say like you walked away for a second, you don't know which fractions, which again, you can come back and look at the trace and you can make a determination based on what you see here. And then if you want a fancy report, you can press archive report. and it gives you a lot of information on what you just ran. I guess it's also worth mentioning, there's actually a USB port here. If you want to take reports off of this instrument, you can go ahead and insert your USB, and then when you press the save button, it save failed because I didn't have anything there, but it will automatically save to whatever is there. It doesn't have really good file I/O, so you can't open anything. You can only save directly to it, and it will just save to whatever folder is like the main folder of your USB, so just be careful of that. So after you're done using the instrument and you're satisfied with your chromatography, the last thing I want to mention is how to turn off the instrument. This is kind of important. As soon as you press the shutdown button, it will ask you yes or no, and when you press yes, to wait for it to prompt you to press the off button. So it's still waiting for everything to close and shutting down. And only when it says it is now safe to turn off the system do you go ahead and flip the switch.